In this video, we discussed the concept of systems of linear equations. Now, a system of linear equations is just a set of two or more linear equations that must be solved simultaneously. So we already know what a linear equation in two variables is, right? It is something of the form ax plus by equals c, where an ordered pair of the form x comma y is a solution of that equation, and there are infinitely many solutions. But now we're going to look at two of those equations, something like dx plus ey is equal to f, and again, that's going to have infinitely many solutions, but for a solution to solve the system means that there has to be an ordered pair that satisfies each of those equations. So that is, we're looking at a line. So I'm just going to draw something like this that maybe goes up from the third quadrant to the first quadrant, and then another line that might start from the second quadrant to the first, and then that common point is going to be the solution that satisfies both of those equations. So graphically, a solution is the point of intersection of the two lines in the system, and algebraically, we can confirm that the ordered pair is the solution by substituting those x and y values. So let me show you that. So in this example, we want to determine if the given point is a solution of the system. And we have a system. We always use this big brace to denote that those two equations have to be solved together. So we have this system of 4x plus 3y equals 15, and y equals 2/5 x minus 1/5. We want to determine if the ordered pair 3, 1 is a solution of that system. Now, we could certainly graph each line and see that 3, 1 is their common point, but an easier way is just to substitute the values of 3 and 1 in for x and y. So we would have 4 times 3 plus 3 times 1, and we want to see, is this equal to 15? Well, that's 12 plus 3, which is 15. So 3, 1 is a solution of that first equation. Now let's check if it is a solution of the second. So y is 1 is equal to 2/5 times 3 minus 1/5. Well, there we get 1 is equal to 6/5 minus 1/5. But that is the same thing as 5/5, which is equal to 1. So therefore, 3, 1 is a solution because it solves or satisfies both of those equations. Now let's look at y equals 1/3 x plus 2/3 and y equals 5/7 x minus 3, and look at, is the ordered pair 7, 3 a solution? So we would have in place of y, 3, and we're asking ourselves, is that equal to 1/3 times 7 plus 2/3? So therefore, we get 3 is equal to 7/3 plus 2/3, which is 9/3, which does simplify to 3. So it is a solution of that first equation. Now substituting into the second. So we get 3, is that equal to 5/7 times 7 minus 3? Well, this is 3 equals 5/7 times 7 is just 5 minus 3, but that is 3 equals 2, which is a false statement. So therefore, 7, 3 is not a solution of the system.